So in a large Midwestern city, a simple random sample of 100 entering freshmen in 2014 found that 20 finished with the bottom third of their high school class. In 2016, simple random sample of 100 entering freshmen found that 10 finished in the bottom third of their high school class. In both years, the entering freshmen had roughly 6,000 students. Let P1 be the proportion of all entering students in 2014 who graduated the bottom third, P2 in 2016 who graduated the bottom third, which represents the 99% confidence interval for P1 minus P2. So 20, so I guess you do 20 divided by 100, I guess, which is 0.2. So that's where you get the 0.2 there and minus the 0.1. Okay, so that's, and they all, like, I like to compare the different answers there. So I can see all those have 0.2 minus 0.1 for your difference in proportion for the p hat 1 minus p hat 2. Okay. So now let's look at the confidence level. It's a 99% confidence level. So I know 95% is 1.96, so it's not one of these. It's got to be 2.56. You could also do inverse norm. Inverse norm of 0.995 should give you that 2.58 number. Okay, so we're down to these two. So which one is it of the two? So so I think it's going to be, actually, so for the formula for standard error for intervals, we use p hat for that. So p hat is 0.2 and then 0.1. Yeah, so it's got to be D. You're just trying to figure out which one works there. And so it's really a process of elimination is one way of doing that. I think you could look at the formula sheet if you're having trouble seeing that was p hat. 68 people from a random sample of 128 residents in Uppala, Sweden had blue eyes. 45 people from a random sample of 110 for Preston, England had blue eyes. Which we'd like to calculate a confidence interval, P1 minus P2, the true difference in proportion, people who have two locations have blue eyes. Which of the following conditions are met? Okay, so for this one, there are at least 1,280 people in Uppala, Sweden, at least 11,000 people in Preston, England. I mean, seems like that's met, right? They'd have to be awfully small towns for that not to happen. Wait, 68 people from random sample. I gotta look at this for a second. Okay, so yeah, it's 120 is the sample size, not the number of residents. So those both seem reasonable. The counts of successes and failures in each sample are at least 10. So there's 68 people were successes there and 45 people, which means out of 128, yeah, there's at least that many successes. 45 out of 110, there's at least that many successes and failures in both. So that seems to work. 2 independent random samples were taken. That might be harder to see. 60 people from a random sample in Sweden and 40 from a random sample in Preston, England. They have to be independent for each other. They're just completely other countries. Yeah, so it has to be, I think it passes all those. At a baseball game, 42 of 65 randomly selected people own an iPhone. Wow. At a rock concert, 34 of 52 people own an iPhone. Researchers wanted to test the claim that the proportion of iPhone users at the two venues is different. The null is, of course, there's no difference. 90% confidence interval for the difference, and we want this order, the game minus the concert, is that, oh, they did it for us. Which of the following gives this correct outcome of the research test at the alpha equals 10% level. Okay, the interval does include 0. The research can conclude the proportion of iPhone users is the same. Well, we can't say it's the same. We never accept the null, right? That was weird wording there at the end, but I don't know if that doesn't sound right. Because the center of the interval is negative 0.008, that doesn't mean anything. The researcher can conclude that it's just silliness. Because the interval does include 0, okay, so now we're talking. That might be something there. The researcher cannot conclude the proportion of iPhone users at the two is different. Yeah, I'm almost positive that's going to be it. That's 100%, right? If 0 is in the interval, it's a plausible value. It's totally possible. There's no difference. Because the interval includes that, you cannot conclude. No, that's not a thing. Because the interval includes more negative. Now, it doesn't matter how many more positive or negatives. It's just that 0, you're really looking at 0. It's 0 in the interval. A study of adverse symptoms in U.S. users over-the-counter pain relief medications, assigned subjects. So assigned subjects at random. So random assignment, which means this is an experiment. One of two common pain relievers. You either get the acetaminophen or the ibuprofen. In all, 650 subjects took the acetaminophen, and 44 took experienced some adverse symptoms. And then 347 subjects took the ibuprofen, 49 had adverse symptoms. So random, you want to check the random sample condition here. No, not random sample. This would be random assignment because it is an experiment. So that needs to be checked. Large counts, for sure that needs to be checked. This is always a questionable one. Is it an experiment? If it is, you don't and probably shouldn't check that one. So 1 and 3 should be the answer there. Suppose you are conducting a significant test for P1 minus P2 is 0, so the null, and then P1 is greater than P2, which the following test is the greatest power. So we want P1 to be bigger than P2. We want P1 to be larger. So that means you're looking for a positive difference, right? So I think right away this guy's gone and this guy's gone. So those are bad answers. We think the sample size should be larger, right? So right away, because that's going to give you, let's see, let's double check that. So the sample size is larger. Type 1 error goes down. Let's see, is the greatest power. So type 2 error goes down, which means power goes up. So I think that's good. And then the alpha level, if the alpha level, remember alpha is the type 1 error. If alpha level goes up, power goes up. So we definitely want the larger alpha level. We don't want one of those guys. So I think we want A. Yeah, so larger sample size, I just want to make sure I had that right. Larger sample size definitely decreases the type 2 error, which is like inversely proportional with power. So if type 2 decreases, power increases there. So it's definitely A. Are women likely to exercise more than men? More likely to exercise than men. A random sample of 250 women found that 59.2% exercise at least 3 times per week. And a random sample of 250 men found that 50% exercise at least 3 times per week. Pretty close, but women seem to be ahead. Some evidence anyway. The proportion of all women who exercise at least 3 times per week is P1, and men is P2 there. We would like to know if there's convincing evidence that a greater proportion of women than men exercise at least 3 times per week. Which of the following pairs of hypotheses are appropriate for this test? Okay, so right away, like some of them that are bad, like that's p hat for no, like that's not going to happen there. So the difference, no, like this is two different proportions, so A doesn't make sense. So these at least, like the null looks like it could be good there. So then what are women more likely to exercise than men? So is the proportion of women, and women is which one, the first one or the second one? Women is the first one there. So we want the proportion of women to be greater, so I think it's got to be C. That was not too bad. 9 students from a random sample of 100 students at the University of Pittsburgh do not like to watch football. 5 students from a random sample of 100 students at Penn State do not like to watch football. If you go to Penn State, I think you have to like football. I don't know what's happening here. We would like to calculate a confidence interval for P1 minus P2, the true difference in the proportion of students from each of these 2 universities that do not like to watch football. Which of the following conditions are met? Okay, these are popular questions here. So these are at least 1,000 students at the University of Pittsburgh, at least 1,000. Well, that's true. I mean, there's a lot of students there. So that'd be 10 times as much as the sample, which would meet the less than 10% condition. The counts and successes and failures in each sample are at least 10. Well, 9 students? I don't think that's met. 2 independent random samples were taken. Random sample at there and random sample at there. Yeah, they're separate, so that seems okay. So 1 and 3? Sounds right to me. A large Midwestern university, a simple random sample of 100 entering freshmen in 2014 found that 20 finished in the bottom third. This is similar to the other problem we were talking about, I feel like. Anyway, so they're talking about the 2 proportions there. Which of the following is the appropriate p-value in conclusion for your test? Ooh, okay, so this is what they give us, right? So if you draw it, like there's 0, 1.9, somewhere out here is your z-value, you're shading to the right. So in your calculator, to figure out the p-value, I think we can just do menu 652. So lower bound seems to be the 1.98. Upper bound infinity, 0, 1, z-scores. So 0.023 or 0.024 if you round it. So I know it's one of these guys. Those 2 are out. So its alpha is that. So if it's 2.3, well, that's pretty small. We're going to reject, right? So we have convincing evidence that the portion of graduate has been reduced. Okay, there we go. 68 people from a random sample of 128 residents in Sweden had blue eyes. I feel like we did this one before too, or at least the scenario part. The p-value for this test is 0.06. Okay, so they gave us the p-value. What do? They gave us the alpha level. Because the p-value is greater than the alpha, we fail to reject. So I know it's not this one. Or I know it's not. Yeah, we're going to fail to reject. Okay, so then the question is, there is convincing evidence if you fail to reject? No. If you do not reject, you do not have evidence. So it's got to be C. Similar sample of 45 male employees at a large company found that 36 felt that the company was supportive of female employees. An independent random sample of 40 female employees found that 24, so 24 out of 40, companies supportive of females. P2 is the proportion of all female employees who hold this opinion. So P1 is the men, P2 is the females. And the men, 36 out of 45. So to be P hat 1, or the men, I'm going to put men there, is going to be 36 out of 45, which is let's type it in. Not to get that one in my head. 36 divided by 45.8. So I see where that comes from there. And the p hat for women is 24 out of 40. Pretty sure that's going to be 0.6. So that's 0.6. And all of them have, well, this one's just bad there. This one's also bad because of standard error there. So it's one of those guys because the numerators are all correct at least. The males was 45. Okay, yeah, that looks about right. Okay, so then this is Z. So we should use, for this guy, we should use square root of P, then 1 minus P. So it's not P hat for this one, I think. So P is, so this is the weird one, right? This is called a 2-prop Z test. And it's really easy to forget that we have to use P hat C here. So x1 plus x2 would be 36 plus 24. And the n1 would be 45, and the n2 is 40. So you really want to type that in your calculator. I have a feeling I can guess what it is here. Just look at the answers, but 36 plus 24 over 45 plus 40. So 0.706. That's where that comes from, the 0.706, so it's not that guy. What's the difference between those two? Oh man, are they the same? I mean, I think they're both right. They're literally the same answer, so it's just a copy. So either one you put, I think would be fine. I can't see any difference between those. Okay. Fashion design is an industry that requires an eye for style and a good sense of business. Those who aim to obtain a degree in fashion must take business as well as fashion courses. Fashion design majors tend to be mostly female. Random sample 100 fashion design majors show that 87% are female, and an independent random sample of 200 business majors show that 52% are female. Okay, that kind of makes sense, that, there's a difference there. So, I mean, it seems like there's a difference. We have some evidence there's a difference, but is it significant? We'll find out. Construct and interpret a 95% confidence interval for the true difference in proportion of fashion design majors that are female and business majors that are female. Okay, so we've got to do the whole 9 yards here. So just kind of think through what the state is for this one. So you want to say like P of M is the true proportion. You just kind of define it. True proportion of all fashion majors who are, maybe I should call this P of fashion, so F there. True proportion of fashion majors who are female, and then P of business, I guess. True proportion of business majors that are female. Okay, we want to talk about the alpha level. Now we're doing interval here, so we don't need the alpha level. We need a confidence level. So 95% confident, so you'd say 0.95% confidence level. Okay, I think we're ready for the plan, so don't forget to name this. This is a 2-prop Z interval. Doesn't seem to be, this is random samples, yeah, so random samples of both the business majors and the fashion majors. We do need to check less than 10%, so what number is 100? So first one's 100 for fashion and 200 for business, is less than 10% of all fashion majors and less than 10% of all business majors. Okay, last one is so n times p, so large counts, n times p hat. So this would be, in this case, I guess the first one is 100 times 0.87 and 100 times 0.13. Those have to be greater than or equal to 10. 87 and 13 are both that. And then 200 times 0.87, sorry, 0.525 over, and then 200 times 0.475. Those are both greater than or equal to 10. Okay, the do section, so you could do the, there's the interval, sorry. So you could do 0.87 minus 0.525 plus or minus 1.96 times square root of. So with this guy, it's p hat 1, so 0.87, and then 1 minus 0.87 over 100. This one over 200, and this would be 0.87. No, this is 0.525, and 1 minus 0.525. Sorry. And you're going to type that in your calculator. I'm just going to do this the old-fashioned way here and go menu 666, I believe it is. Number of successes. So that was 87 for the first one, 87 out of 100. The second one was I need to do that again. So let's do 200 times 0.525. So 16. So 87 and then 16. So menu 666. 87 out of 100 and 16 out of 200 and 95%. So we should get 0.714, 0.866. We are 95% confident. See if you do a conclusion. We are 95% confident the interval from 0.714 to 0.866 contains the true proportion difference between the percentage or proportion of females at fashion majors or business majors. Our PTAT. Yeah, okay. Explain what is meant by 95% confidence level. So that means if we took many samples, we created many intervals, about 95% of the intervals would contain the true proportion of the difference in proportion of women majors proportion of women who are majoring in fashion as opposed to the proportion of women who are majoring in business. Based on the confidence intervals, is there convincing evidence the true proportion of fashion are different than the proportion of business majors? Let's look. Is 0 in the interval? No. Since 0 is not in the interval, we don't have evidence that there is a difference in the proportions. 0 is a plausible value. There could be no difference. It's definitely possible. Just going to show you the answers for that one if you needed it. Hopefully we hit all those about right. So one more long problem here. Oh, I guess two more, but this one's the last. This one's a test, I believe. So this would be a little rough. They had a company picnic and a bunch of people got sick. Company doctor suspects the illnesses may be related to the fish, one of the options for the main course. Because the dinner guests had to pre-order their meal, the doctor was able to randomly select and contact 80 people that ate the fish, of which 64 got sick. Ouch. Also contacted 60 people that did not eat the fish, and 39 people got sick. Oh, maybe it wasn't the fish. Doctor knows at least 1,000 attendees ordered the fish. Okay. Is there convincing evidence the true proportion of all attendees who ate the fish got sick, more than those who did not eat the fish that got sick? Okay. So what's in the state here? So we want the alpha level, 5%. P sub, let's see, define the true proportion here. The fish, and then the no fish. True proportion of fish eaters who got sick and true proportion of the no fish eaters who got sick. So the null is P of fish equals P of no fish. Or you could say, that PF minus P no is equal to 0. The alternate, do they give us a direction here? So we think maybe that the one that ate the fish got more sick, so a higher proportion there. So the fish is greater than the no fish. Okay, so we have our things there. So we want to call this what it is. It's a 2-prop z-test. If you call it with a formula, that counts. So name or formula. Some people use the z-score and don't write this down or just forget to write this down, but they do z, they're covered if they do the equation there. Conditions, I'm hoping these are randomly selected. Yes, they are. Random samples, plural, of those who got sick eating the fish, and those who got sick not eating the fish. Less than 10%. So what was the first one? 80 is less than 10% of all the folks, and 60 is less than 10% of all those folks. Okay, so then, and so for this one, we have to do that weird thing. So it's the p hat c. So you're going to add up the number of successes. So 64 out of 80 plus 39 out of 60. And you get your p hat combined. And then you can use that to check the condition. So sometimes I do this. Sometimes I go mini 676 here. X1 was 64 out of 80. And X2 was 39 out of 60. And we think the alternate is greater than here. So by the way, this p hat combined is going to be 0.736 here. If you look at the answer, this one is p hat combined. It's really nice to know that. Okay, so we're going to use that when we check the conditions. So that's going to be n, which is 80, times 0.736, which should be greater than or equal to 10. 80 times 1 minus 0.736 should be greater than or equal to 10. And then 60 times 0.736 should be greater than or equal to 10. And 60 times 1 minus 0.736 should be greater than or equal to 10. Okay, then we do the do section. Well, we could do the do section, just write down the two things we know. Z equals 1.992. P-value 0.0232. Okay, you could also do your z-score, right? So z equals, subtract the two proportions there. So p at 1 is 0.8 minus 0.65. And this would be a p hat combined, which is 0.736 times 1 minus 0.736 plus, that one was over 80, this one's over 60. Same numerator here, so 0.736, 1 minus 0.736. Once you get those, you could do, of course we already know the p-value, but you could do, once you know the z-curve, so you go norm CDF 1.99, comma infinity, comma 0, comma 1. I think that's what we got, 0.023, yeah. Okay, so because our p-value is less than our alpha level of, I think it was 5%, yeah, we do reject the null. We do have evidence to say that there were more fish eaters who got sick than others there. And last, based on conclusion, which error could you have made? Interpret the potential error. Based on your conclusion, will be rejected. So that could be a type 1 error. It can't be type 2 if we rejected. That would be failed to reject. So we rejected the null. The null again was, there's no difference between the fish group and the no fish group. A proportion of folks who got sick. There's no difference. Interpret, so what would that be described as? So that means that we think, we thought the fish group got sicker, bigger proportion of fish group got sicker, but actually if it was type 1 error, that would mean, no, that's actually not true. That's not the case. Let's look at 12 for that one, just so you have it. There's the answers. Okay, and finally 13. An insect ecologist reports a 95% confidence interval for the true mean length of full-grown aquatic larvae, 6.9 to 8.5. Determine the point estimate. So 6.9 and 8.5. So 6.9 plus 8.5 divided by 2, 7.7. And the margin of error would be 8.5 minus 7.7. 8.5 minus 7.7. Sorry, which is 0.8. Explain what would happen to the width if the confidence level were increased. So if alpha is increased, power goes up. I know they didn't maybe ask about that, but that's true. So what would happen to the width? So if alpha goes up, I know like 99% is 2.58 compared to, the 95%. So it's going to make the interval wider. It's going to get wider. So he's unhappy with how wide his interval is. What should you do to produce a narrower interval? So increase the sample size. I think decrease the alpha. Let's see what they said. Larger sample. It said one reason. So that's okay. Explain. So increasing the sample size. So they said for that one, you should take a larger sample to produce a narrower interval with the same level of confidence. Reduce the standard deviation, make the interval narrower. It's always better, you're right, to increase the sample size. It's going to decrease the width. It's going to be a better estimate.